Good day! Today we will be having lesson number 7 entitled The Central Limit Theorem. Let's have the learning competencies and specific objectives of this session. Learning competencies. The learner should be able to, number 1, illustrate the central limit theorem. Number 2, defines the sampling distribution of the sample mean using central limit theorem. Number 3, solve problems involving sampling distribution of the sample mean. And for the specific objectives, you as a student are expected to, number 1, describe and interpret central limit theorem and its relation to sampling distribution. Number 2, calculate the probability or sampling distribution using the z-score. And number 3, appreciate the importance of central limit theorem in conducting research or studies relevant to life occurrences. Let us recall. You will answer the activity number 1, Who Am I? Statistician Edition. You will check your answer honestly and add up your scores later. Your scores will tell you who your statistician alter ego is. After checking, count your score and take a screenshot of the corresponding pictures of your score to be flashed later. Put your picture, name, and post it in your My Day or wall. Solve for the sample mean below. So there are 5 families undergone COVID-19 vaccination. The following are the number of family members who were vaccinated. 1 member from the first family, 2 members of the second family, 3 members of the third family, 4 members of the fourth family, and 5 members of the fifth family. So we have a set of 1, 2, 3, 4, and 5. Let us try to get the sample mean of the following in 2 decimal places. So here are the sets. Number 1, we have 1, 3, and 5. What is the sample mean? Number 2, 2, 3, and 4. What is the sample mean? Number 3, we have 3, 4, and 5. Number 4, we have 1, 2, and 4. And for the number 5, we have 1, 2, and 5. I am expecting that you are already done answering the activity number 1, so it's checking time. Let us check your answers. For the number 1, we have a set of 1, 3, and 5, and the sample mean of 1, 3, and 5 is 3. For number 2, we have 2, 3, and 4, and the answer is 3. And for the number 3, we have 3, 4, and 5, and the sample mean is 4. For the number 4, we have 1, 2, and 4, and the sample mean is 2.35. For the number 5, we have 1, 2, and 5, and for the sample mean, we have 2.67. It is time for you to count your scores and screenshot the next slide. So now, get a screenshot and edit this if your score is 5. Congratulations! Your statistician alter ego is Johann Carl Friedrich Gauss. Get a screenshot and edit this if your score is 4. Congratulations! Your statistician alter ego is Florence Nightingale. Get a screenshot and edit this if your score is 3. You've made this far. Your statistician alter ego is Carl Pearson. Focus! If your score is 2, your statistician alter ego is William Seeley Gosset. Try hard next time. If your score is 1, your statistician alter ego is Ronald A. Fisher. Please study harder. If your score is 0, your statistician alter ego is George Bucks. Before exploring the topic, there are words that we need to remember. So let us answer the activity number 2, crossword puzzle. Solve for the crossword puzzle to identify the terms that you will be encountering in this lesson. There will be some clues to be flashed. You may pause this video to answer this activity number 2. I am sure that you are finished solving the crossword puzzle, so let us check your answers. For the down, we have number 1, a distinct group of individuals, whether that group comprises a nation or a group of people with a common characteristic. For number 1, we have population. Number 2, It refers to a smaller, manageable version of a larger group, and that is number 2 is sample. Number 3, the average, the most common value, and the expected value in a collection of numbers, and that is mean. And for the across, we have number 4, a statistical measurement of spread between number, or how far each number in a set is from the mean in a data set. We have number 4, variance. For the number 5, we have the number of observations taken from a population, and that is size. If you get 5 correct answer, very good. So let us proceed now to the next. What's in? We will explore the central limit theorem by answering the activity number 3, community pantry statistician. In here, we have a situation that you're going to answer, and you may write your answers and solutions in your notebook or a piece of paper. Later on, we will go in to check that. So going back to the situation, the barangay captain noticed that sometimes the kilos of rice in the community pantry is less than and wasn't enough for the people who need them. You, as a statistician student, have given a task by your captain or the barangay captain to get the average kilos of rice taken by families in the barangay where you live. The following kilos of rice as the data you gathered in 20 families are 1111, 2222, 33333, 4444, 55, and 5. So you are going to answer the following questions. Number 1. What is the mean if you randomly take the kilos of rice of 5 families as follows? We have 1, 2, 3, 4, 5. So what will be the mean? Next, number 2. What is the mean if you randomly take the kilos of rice of 10 families as follows? We have 1, 1, 2, 2, 3, 3, 3, 4, 4, and 5. What will be the mean? Next, number 3. What is the mean if you randomly take the kilos of rice of 15 families as follows? We have 1, 1, 1, 1, 2, 2, 3, 3, 3, 3, 3, 4, 4, 5, and 5. So what will be the mean of this 15 families, or the kilos of these 15 families? You may pause this video and solve this in your notebook and play this if you are ready to check your answer. Let us check your answer for the activity number 3, which is about the community pantry statistician. Going back to the questions, we have number 1. What is the mean if you randomly take the kilos of rice of 5 families as follows? We have 1, 2, 3, 4, and 5. So if you're going to get the mean, we are going to add all the numbers 1, 2, 3, 4, 5 and divide it by 5. And the average kilos of the rice of the 5 families in the barangay is 3. So that means 3 kilos, almost 3 kilos for the 5 families. Next, we have number 2. What is the mean if you randomly take the kilos of rice of 10 families as follows? We have 1, 1, 2, 2, 3, 3, 3, 4, 4, and 5. So add all those numbers, divided by 10, and you will get the average kilos of rice of the 10 families in the barangay is 2.8. And for number 3, what is the mean if you randomly take the kilos of rice of 15 families as follows? We have 1, 2, 1, 1, 1, 1, 2, 2, 3, 3, 3, 3, 3, 3, 4, 4, 5, and 5. So add all those numbers, divided by 15. The answer will be the average kilos of rice of the 15 families in the barangay is 2.73. So I hope you get all the correct answers for these 3 questions. So this activity will lead us to the definition, characteristics, and different concepts about the central limit theorem. So let us try to answer this in your notebook. What can you say about the sample means of 5, 10, and 15 families? After this activity, what do you think is the central limit theorem? So as we go along the lesson, you will be having much clearer definition, much clearer answer to these questions that we have. In the preceding session, we will answer these following questions about central limit theorem. What is central limit theorem? What are the characteristics of central limit theorem? What are the important key concepts in understanding central limit theorem? What are the 3 components of central limit theorem? And what is the importance and application of central limit theorem? What is it? To answer our questions earlier, let us try to do this activity to further help us in understanding the central limit theorem. So for the activity number 4, let us investigate. We are going to observe the data gathered from the activity number 3, which is the community pantry statistician, and answer the processing questions below. So here is the table of the data that we gathered from the activity number 3. So we have the population, which is equals to 20, and the sample distribution of the mean, where we pick 5 families, and we got another one, which is 10 families, and we randomly picked 15 families, where each of this n has its own mean and the standard deviation. So for the population, we have the respondents of 20 families. For the mean, we have 2.9, and for the standard deviation, we have 0.5. So for the randomly picked families of 5, the mean that we get from these 5 families is 3, and the standard deviation is 0.58. For the n, we have 10 families. The mean that we got from the data earlier is 2.8, and the standard deviation is 0.55. And for the n, which is 15 families, the mean is 2.73, and the standard deviation is 0.53. So going to the processing questions, let us try to solve this or to answer this in your notebook. Write your answer, and later on we will going to check. So for the first processing question, what is the size of the population and the other 3 samples? You can enumerate those sizes from the population and the other 3 samples. So number 2, what do you notice about the values of the sample mean and the population mean of the sampling distribution as the sample size increases? Next, number 3, what do you notice about the values of the standard deviation of the sampling distribution as the sample size increases? And number 4, what can you conclude about the sample mean, sample standard deviation, and the sample size, or as the sample size increases? It's checking time. You are now going to check your answer for the processing questions in the activity number 4. To begin with, here are the processing questions earlier. Number 1, what is the size of the population and the other 3 samples? The answer is, the size of the population is 20, while the other 3 samples being randomly picked are 5, 10, and 15. So these are the families in the data. Number 2, what do you notice about the values of the sample mean and the population mean of the sampling distribution as the sample size increases? So, as the sample size increases, the values of the sample means approach near the value of the population mean. So it becomes normal. Number 3, what do you notice about the values of the standard deviation of the sampling distribution as the sample size increases? As the sample size increases, the standard deviation decreases its value. Number 4, what can you conclude about the sample mean, sample standard deviation, and as sample size increases? As the sample size increases or approaching to the population size, the sample mean approaches to the population mean, and the standard deviation decreases its value. So the distances becomes smaller and smaller for the standard deviation. I hope you get the correct answer for this, because this activity or this processing question will help you to solve or to give answers to the previous questions that I have posted. Previously, we asked different questions regarding central limit theorem, such as, what is central limit theorem? What are the characteristics? What are the important key concepts in understanding the central limit theorem? What are the 3 components? And what is the importance and applications? So we are going to answer that in this part of the video. I hope from the different activities you've gone through, you will be able to answer these particular questions. So let me hear you first answer this question. What is central limit theorem? Very good. So to further give you the definition of central limit theorem, if random sample size n are drawn from a population, then as n becomes larger, the sampling distribution of the mean approaches the normal distribution, regardless of the shape of the parent population. So this definition is supported by the activity that we had in activity number 3 and 4, wherein we answered the processing question, right? So there in the question, what happens when the n becomes larger? So the mean of the sample becomes approaches the population mean. Another is that it states the sampling distribution of the sample means approaches a normal distribution as the sample size gets larger. So no matter what the shape of the population distribution, so it means that even when you get different sample sizes of the population, it will still be approaches near the population mean. Another question, what are the characteristics of central limit theorem? Actually, the processing questions that we have answered and checked from the activity number 4 will tell us what are the characteristics of the central limit theorem. So let us identify those. Number 1, as the sample size increases, the values of the sample means approach near the value of the population mean. Thus, it becomes approximately normal. So as soon as the sample size increases, it approaches the population mean. That is why it becomes more normal. Next, number 2. As the sample size increases, the standard deviation decreases its value. So as long as it gets higher, the sample size increases, then the scores, the distance of the scores into the mean becomes closer. So it becomes more homogeneous. Number 3. As the sample size increases or approaching to the population size, the mean approaches to the population mean and the standard deviation decreases its value. So therefore, these characteristics implies the true definition of the central limit theorem. What are the 3 components of central limit theorem? So when we talk about central limit theorem, we always mention these components. Number 1, mean. Number 2 is the variance or the standard deviation, and number 3 is the size. So remember, the measures that we use in the population and samples are called statistics and parameter. When we say statistics, it is a measure that being used for the sample, and the parameter is being used as the measure for the population. So let us have the mean. So the symbol for the mean in the sample is x bar, while in the population we have me or mu. For the variance and the standard deviation, for the sample size we have s squared for the variance and the standard deviation as s, while for the population we have sigma squared for the variance and the standard deviation as sigma. And number 3, we have the size, wherein in the sample we have a small n, and for the population we have the big or the capital N. What are the important key concepts in understanding the central limit theorem? See, we always remember this, that the sample size and the population size, as the sample size increases, the more the distribution becomes normal. So we always talk about size or sample and population size. For number 2, the mean, the average of our sample means will itself be the population mean. So that means that the sample means is also equal to the population mean. Number 3, the standard deviation of the sample means equal to the standard error of the population mean. What is the importance and application of the central limit theorem? So the central limit theorem tells us that no matter what the distribution of the population is, the sample or the shape of the sampling distribution will approach normally as the sample size increases. So if the distribution is not normal, then we can use the central limit theorem to create or to make the population become more normal. So as you can see here in the graphs, we have n is equal to 1, which means that the sample size is 1, n is equals to 5, the sample size is 5, n is equals to 10, so the sample size is 10, and we have n is equals to 20. So as you get increasing sample size, the graph or the figure of the graph becomes more curved or normally curved. So that is why it is very important that when we increases the sample size, it becomes again approximately normal. Alright, so for the application, if the distribution is not normal, we consider the sample distribution to be normal according to the CTL or the central limit theorem, as this method assumes that the population given is normally distributed. This helps in analyzing data in methods like constructing confidence interval. So just like the importance of the central limit theorem, it gives us the option to use sample sizes or different sample sizes for us to make the population becomes normal. So to estimate, again, for the application to estimate the population mean more accurately, so we can increase the sample size or the samples taken from the population, which will ultimately decrease the sample means deviation. So as we have said earlier, as we increase the sample size, we also approaches the population mean and decreases the deviation or the closeness of the scores or data. So another application is to create a range of values which is likely to include the population mean. So we can use sample mean. So which means if you are going to conduct a research or a study, you are going to use sample mean as a way of conducting the research, because when we use the population mean, it's too much and we cannot able to get a survey to all the Filipinos around the country. So that is why we use the sample mean to represent the entire population. What's more, so in this session, we will be applying all the things that we have learned from the central limit theorem. So here we are going to solve problems on central limit theorem. So from our original formula of the z-score, we have z is equal to x minus me or mu divided by the sigma. We now have this new formula if you want to compute for the probability that x bar will take some values in the sampling distribution of x bar. So remember, x bar is represents the mean of the sample. So the formula will become z is equal to x minus me over sigma divided by the square root of n. So remember, x bar is the sample mean, me or mu is the population mean, sigma is the population standard deviation, and n is the number of sample size. What's more, so in this session we will dealing with solving problems on central limit theorem. So we will going to calculate the probability of the following. So the number of vaccinated in each barangay per day are normally distributed with a mean of 7 to 8 people and a standard deviation of 6. If you as the researcher will select at random letter A, what is the probability that the number of vaccinated in your barangay is higher than 90 people? Okay, letter B, what is the probability that the number of the vaccinated in your barangay is less than 75 people? And letter C, what is the probability that the 30 barangays will have an average vaccinated people of less than 75? So we are going to solve for the probability of the following. Going back to the problem in what's more, so we have the number of vaccinated in each barangay per day are normally distributed with a mean of 7 to 8 and a standard deviation of 6. If you as the researcher will select at random, let's go with letter A, what is the probability that the number of vaccinated in your barangay is higher than 90? So in here, we have to show the solution. How do we solve for this problem? So first, get the given. What are the given in the problem? So we have a mean of 7 to 8 people and a standard deviation of 6. And also it is stated that the population is normally distributed. Okay, using this given, we are going to solve letter A. So it says there that the probability that the number of vaccinated in your barangay is higher than 90. So we can say that the probability of X higher means greater than 90. So we have P of X is greater than 90, and we are going to convert these raw data of X into z-score. So we have P of z is greater than the unknown. So what is the equivalent of 90 if we transpose this or convert this into the z-score? So how are we going to solve for this? We are going to use the z formula earlier that we have discussed. We have z is equal to the x minus me divided by the sigma. So let us convert x to z-score. So we have z is equal to x minus me over sigma. So based on the given, our x will be the 90. So we have 90 or greater than 90, right? So we have 90 minus 78 as the population mean divided by the sigma, which is 6. So 90 minus 78 is equal to 12 divided by 6, the sigma. So you'll get 2.0. So after getting the z, we are going to use the table of values of z to determine the required area or the probability of that getting higher than 90. Okay, so now using the z-score of 2.00, we could able to determine the probability of getting higher than 90. So using the table, okay, so look into our z-score. The first whole number and the first decimal or the 10th place will be in here at the first column, which is the red columns, and the second decimal place or the hundredths you will use the draws from this blue row or the first row. Sorry. So with that, we are going to search for 2.0, and 2.0 is in here, while the second place of or decimal place is 0. So we have 0.0, which is in here. So we can say that 2.00 has a value of, or the area of 2.00 is 0.9772. So with this, we could able to find or to get the area and probability of the number higher than 90. Okay, so we can say that the probability of x is greater than 90, where p of z is greater than 2, since our z earlier that we solved is 2. That is equal to 0.9772 by using the table. So therefore, we can say that the probability that the number of vaccinated in your barangay, of the people vaccinated in your barangay, is higher than 90 is actually 0.9772 or 97.72%, which means they will have higher than 90 patients or number of people that will be vaccinated. So after solving letter A, let's go with letter B. So in letter B, what is the probability that the number of vaccinated in your barangay is less than 75? Okay, so again, to show you the solution, first get the given, which is we have the mean or the population mean of 78 and a sigma of 6, and also we stated that the population is normally distributed. And looking at letter B, we have a clue there that it says less than 75. So therefore, the probability of getting the x, which is less than 75, is equal to less than 75 is equal to the probability of getting z, which is less than the unknown, which is we are going to solve for that value. Okay, so using the z-score or using the z formula, so let's convert the x into z. We have z is equal to the x minus me divided by the sigma, and our x here is 75 since we are talking about less than 75, and our me, which is 78, and our sigma is 6. So we have 75 minus 78 divided by 6, and you'll get -3 divided by 6, and -3 divided by 6 is equivalent to -0.50. Okay, so therefore we can say that the z in here is -0.50. By using the table of values, to determine the required area of the number of vaccinated, which is less than 75. So we're going to use again the table. So here in the table, we are going to look for the value of negative 0.50. So the first whole number is negative 0. And the first decimal place is 5. So we have 0.5 or negative 0.5. So in here, at the table, we can find it right in here. So we have negative 0.5. While the second decimal place is 0. So therefore, in the blue column or the second blue column, so we have 0.0. Therefore, putting them together, crossing each one another, you'll get the value of negative 0.50 as 0.3085. So after getting the area using the table, we can say that the probability of x less than 75 is also equivalent to the probability of z less than negative 0.5, wherein the value of negative 0.5 is equal to 0.3085. So we can say that, therefore, the probability that the number of vaccinated in your barangay less than 75 is 0.3085 or 30.85%. So it's lesser than the previous probability that we get at letter A. So it would be less to happen. Okay, so let's go with letter C. So what is the probability that 30 barangays will have an average vaccinated people of less than 75? So to show your solution, first get the given. So in here we have the population mean is 78, the standard deviation is 6, and it's stated that the probability or the population is normally distributed. And for the letter C, we have another given, which is 30 barangays, which means it will be the sample size of the data in the barangay. So we can say that the P of x bar is less than 75. So we're still looking for the probability that less than 75. So we can say that the P of x bar is less than 75, wherein it is also equal to the probability of z less than the unknown, which we are going to convert the value of x bar into the z score. Okay, so let's convert the x bar into z score. So z is equal to, so now we are going to use the second formula, or the new and modified formula. Specifically, if we are going to get sample size from the population. Okay, so it becomes x bar minus me over sigma over the square root of n. So our x bar here is 75, because we are going to get the probability of less than 75, so that's why we get 75. And the population mean of 78 over 6 divided by the square root of 30. Okay, so in solving this, 75 minus 78 over 6 square root of 30, you'll get negative 2.74. And having this, we can use the table of values to determine the area or the probability of negative 2.74. So by using the table, we are going to look for negative 2.74. So in here, we have the first place, or the whole number, sorry. The whole number is negative 2. And for the first place or decimal place is 7. So we have negative 2.7. So you will look for the first column, which is the red columns. Look for negative 2.7. So in here, we can say that the negative 2.7 is right over here. And after negative 2.7 is 4. So we are going to look into the rows, the first rows, which is the color blue, or the blue one. So we have 0.4 is right in here. So if we are going to connect these two, the negative 2.7 and 0.04, you'll get 0.0032, if I'm not mistaken. 32, 31, okay. So we can say that the probability of the x bar is less than 75, and this will be converted into Z. We have the probability of Z less than negative 2.74, and we get the area of 0.0031. So using this area, we can therefore conclude that the probability of sample 30 families in the barangays will have an average vaccinated people of mean less than 75 is 0.0031 or 0.31%. So the probability is very small. We can say that based from out of those 30 barangays, most of them has the probability of getting less than 75 is 0.31, which is very, very low. What can I do? So in this session, you will going to apply what you have learned in solving problems regarding central limit theorem. So you are going to try this on your own. You may get a piece of paper or your answer sheets to write your solutions for this. So activity number 5, O vaccine, my vaccine. You, as one of the researchers of Pfizer-BioNTech vaccine for COVID-19, has observed that the amount of the vaccine in the vial or the bottle is normally distributed random variable with a mean of 0.30 ml and has a standard deviation of 0.05 ml. So your task here is letter A. If a patient wants to be vaccinated, what is the probability that the vial will contain less than 0.26 ml? Letter B. If the patients will consume 10 vials, what is the probability that the mean amount of the 10 vials will be greater than 0.26? So you may pause this video for you to have time calculating and solving this problem. You may proceed if you are finished or done doing this activity. What I have learned. In this part of the video, you are going to answer the following questions. So activity number 6, what I have learned. Letter A. When drawing samples of size in N from a very large population, number 1, thus the value of the sample mean is the same as the population mean. Explain your answer. Number 2, explain central limit theorem in proving the similarity results of sample mean to the population mean. Letter B, how do you solve problems on central limit theorem? Letter C, having the population gives you more accurate data to be used in interpreting data and making decisions. So do you think you can make a research with the entire population or the entire people of the Philippines as your respondents? Why? Letter D, is it okay to use a small portion of the population? Explain your answer. You may pause this video for a while for you to have time answering this activity number 6. And if you are through with this, you may resume playing this video. Assessment. So in this part of the video, you are going to solve or to take this quiz in solving central limit theorem. You are going to show your solution in your paper or answer sheet. Okay, so number 1, the time it takes a group of grade 11 students to complete the final exam in statistics and probability is known to be normally distributed. The mean is 58 minutes and the standard deviation is 4 minutes. So letter A, what is the probability that the random selected student will complete the examination in less than 54 minutes? 5, if a randomly selected student take the exam, what is the probability that the mean time it takes the group to finish will be less than 54? Alright, number 2. The amount of cholesterol in each pack of instant noodles was found to be normally distributed. The mean is 450 milligrams and the standard deviation is 3 or 30 milligrams. Letter A. If a pack of these instant noodles is chosen at random, what is the probability that the cholesterol content will be more than 475 milligrams? Number 5, if a sample of 10 packs of these instant noodles is selected, what is the probability that the sample mean will be more than 475 milligrams? You may pause this video for you to have time solving and calculating for the probability using the central limit theorem. So congratulations, you are almost done. So let's go with the last part of this video, the assignment. So for your assignment, answer the following questions. Number 1, what is the t distribution? Number 2, what does the degree of freedom mean? And number 3, how can you solve for the t-score? Thank you very much and congratulations, you are done answering the lesson number 7, which is about the central limit theorem. See you to the next video lesson. Bye!